Retry this again. Hello, Steve. Hello, Steve. All right, so we're doing rotation of conics. What's going to happen is you're going to take the conics that used to go up and down, horizontal and vertical, and you're going to rotate them. The reason why you have to rotate them is, and I think of like problems like with sound problem, it makes more sense to have, more realistically, would be people that didn't live directly north or south or east or west. Up until this point, you have only had a coefficient for ax squared and then c squared and cy squared. You didn't have a term that had both b, the b term that had both x and y times each other. And once I have that term, that means that conic is no longer vertical or horizontal. It rotates. And so the first thing we're going to have to do is we're going to have to find the angle of rotation, and then we're going to learn how to graph the new conic on that new axis C.
Oh boy.
Okay? It's not as bad as it sounds.
I'm sure. And there's some trigonometry.
Oh, there's a lot of trigonometry.
Oh, I'm very good at trigonometry.
So what we're going to do is we're going to start off with the equation that has that bx term, and you're going to rewrite it in a way that you eliminate that bx term. So you're going to see these prime symbols. They mean that it's the same equation, except for your a is going to change values. Your x that you substitute in is going to be different than just plain old x. And in order, what we're going to do is we're going to find out how far we rotate the conics, and that's the very first thing we're going to do. And that formula here, which you kind of have to know, so you might as well circle it or something, is that cotangent of 2 theta is equal to a minus c over b.
We have to take a test on it. We're going to get a formula sheet.
Yes.
Thank the Lord.
So in order to find the coefficients for the new equation, remember this here is going to be our new equation. In order to find the new coefficient for A and C, we're going to have to substitute in that angle that we find here, and we're going to come up with a new x, and we're going to come up with a new y. So let's do a baby one first. So let's suppose I have a point 3, 1 on my regular xy axis. So if I ask you to graph 3, 1, everyone should be able to graph that 1, 2, 3, 1. There's that point right there. 3, 1. What I'm going to do is I'm going to rotate the axis about 60 degrees. So eyeballing about what 60 degrees would be. I would have this. This would be my new axis. This would be my new y-axis, and I want to find out what this point would be if I were to rotate it. So in order to visualize rotating,
do they always rotate together?
Yes, the x and the y. Yes. So what you're picturing that you're taking this axis and you're rotating it like that, and then I want to find out what the new ordered pair would be to represent that point right there. So if I can guess, I know my x is still going to be positive, but my y is going to be what kind of value? Negative. So I can guess it that much that I know. So in order to find the new point, I'm going to go back to these equations here, and I'm going to substitute in the 60 degrees to find my new x and my new y.
So the point stays where it's at? Your axis is just changing?
Yes. So let's copy these over where you have them on your piece of paper. So we're going to substitute those in. We're going to substitute 60 degrees in for that theta, cosine of theta, which means you need to know values from your unit circle. So to find x, well, I know x. X is 3, right?
Yeah.
So 3 is equal to the new x times the cosine of 60 degrees minus the new y times the sine of 60 degrees. That's one equation. What is cosine of 60 degrees?
Square root over 2. I have no clue.
1 half?
That's 45. Wait, is that 45? Yeah.
How does test do the circle?
Is it 1 half?
You can make your own.
So we need to memorize the unit circle.
We need to relearn the unit circle. Don't memorize. You need to know it from now until at least the end of next year.
I don't remember.
Everyone's good with that, right? Now I'm going to do the one that says y equals something. So in this case, my y is 1. So I'm going to say y is equal to the new x times the sine of 60 degrees plus the new y times the cosine of 60 degrees. You have 2 equations, 2 unknowns, otherwise known as a
Sadness.
system of equations. So I'm going to put them underneath each other and then try and figure out what I want to multiply by to. What do you think you want to I'm probably going to do elimination. I'm going to do substitution. I'm probably going to do elimination. What do you think I want to multiply by to eliminate one of my variables? I could, the easiest thing to do would probably be multiply this one by the square root of 3, because these two are already opposites. So if I do that, the first equation will stay the same. And now the second equation will become the square root of 3. And then the square root of 3 times the square root of 3 would just be 3, right? When I add 3 plus the square root of 3, I'm just going to write 3 plus the square root of 3. They're not like terms I cannot combine them. 1/2 plus 3/2 would be 2. And then these are opposites, so they'll be eliminated. Divide both sides by 2. So I'm going to have the new x is equal to 3 plus the square root of 3 over 2. Once I have the new x, how do I find my new y? Plug it in. Do you care which equation I use?
Hello.
So you want me to take this and put it in here for this one? Okay. So I'm going to say 3 is equal to 1/2 times 3 plus the square root of 3 over 2 minus square root of 3 over 2. How would I do?
Multiply. Oh, we already did it.
You know what I'm going to choose to do? I'm going to choose to add the square root of 3 over 2 y and subtract this. You're okay with that? So I'm going to have the square root of 3 over 2 times the new y. And then when I subtract this 3, I subtract the 3, that's minus 12 fourths, right? You good with that?
Can you go back to the 3 equals 1/2? And then, how did you get the next one?
Here to here, I just multiplied the 2 and the 2. And then I'm going to have -9, I believe, right? Now what do I do?
Multiply by 2 over square root of 3.
That's what I'm doing. 2 over the square root of 3. 2 over the square root of 3. Here the 4 and the 2 will simplify and I'll be left with 2 here, right? So this will just be the new y. This, can I write 9 over 2 times the square root of 3? Everyone with me? Plus the square root of 3 over 2 times the square root of 3.
Okay, so why did you draw this?
Because when I multiply, the 4, I'll divide 4 by 2 and 2 by 2. I'll simplify.
Why did you do negative?
is fun.
It is fun.
I like the second one.
So if I left it like this, and then this will simplify, and this is times 1 over the square root of 3, right?
The 3 on one side, I don't know what
You think it comes to -9.
The 3 that I had on this side, when I subtracted it from both sides, I wrote it as -12 over 4. That's why I got the -9. When I do this, I'm going to go term by term because I think that's easier. So we have -9 over 2 times the square root of 3 plus the square root of 3 over 2 times the square root of 3. This one is easy. This is just 1/2, right? In order to do this, what do I have to do?
Rationalize.
I have to rationalize. So I'm going to multiply by the square root of 3 over the square root of 3. When I do that, this would be -9 times the square root of 3, and then this would be over 6. But the 6 and the 9 can simplify, right? So -3 square root of 3 over 2. Everyone with me? So the new y is equal to -3 times the square root of 3 plus 1, and this is all over 2.
How did it become -3?
When I rationalize and multiply by the square root of 3 over the square root of 3. What the heck?
5.
When I rationalize and multiply by the square root of 3 over the square root of 3, when I multiply this is 9 times the square root of 3,
Yeah.
and then this is 3, so I ended up with 6.
Yeah.
3 will go into 9 3 times, 3 will go into 6 2 times.
Okay.
So my new ordered pair for that point is going to be 3 plus the square root of 3 over 2, and then -3 times the square root of 3 plus 1 over 2. This is a baby problem. Yes.
So they probably didn't.
Well, I can. So do me the favor, find a decimal for 3 plus the square root of 3. For just for this demonstration of visual points, yes. Yes. 2.36, and what's the other one? -2.09. So if I go back up here where I started, this would be about, so this would be about 2 point whatever, and this would be down about 2. So it doesn't matter what I have it on. Like this would be 1, 2, 3, so that's about 2 point whatever, and then this would be 1, 2.
So
It matches.
it was.
Okay? Now, I say this is a baby one because we just found 1 point. We have to find the entire equation next. Which sometimes is easier, sometimes not. Well, you'll tell me, I'm sure. So let's start off. This is a baby equation. So I have xy plus 2 is equal to 0. So I have an xy term, which means I have to rotate it. Okay? I'm going back to this formula here that said that the cotangent of 2 theta is equal to a minus c over b. Just to remind you, the a is the coefficient of the x squared, the b is the coefficient of the xy term, and the c is the coefficient of the y squared term. Okay, so I'm going to go here and I'm going to substitute in what I know. So if I asked you, what's your a in this case? What's your coefficient of x squared? 0. What's your b?
1.
1. What's your c? 0. C is the coefficient of the y squared term. So I'm going to say the cotangent of 2 theta is equal to 0 minus 0, that's a minus c over b, which is 0. So since this is 2 theta, I'm going to go over here and ask myself, when is the cotangent equal to 0? Cotangent is what over what? What trig function over what trig function? Cosine over sine. So when is your cosine 0 And that would mean that your sine would be 1.
0 and then pi.
Pi over 2, which is how many degrees?
Oh, wow.
90. So
Whoa.
this, in this case, actually would be 90 degrees or pi over 2. So that means that this cotangent of 2 theta is equal to 90 degrees, or if you're doing radians, pi over 2. Which means what's 1 theta equal to?
Well, how does the two change it?
Actually, because this is 2 theta, so 2 theta is going to equal 90 degrees or pi over 2. Because that's when your cotangent is equal to 90 or theta. So 1 theta is going to equal what? 45 degrees or pi over 4. So now we know how far we're doing our angle. So now we know what we're going to substitute in to find the new x and the new y. Yes? Oh, we
want the two theta.
well, this is a formula. The formula is for 2 theta.
So we use the two theta one to find.
The formula says 2 theta. So if you were to do on your calculator the inverse cotangent, and we'll do some that aren't this nice. If you do the inverse cotangent, your calculator is going to give you 90 degrees or pi over 2. You need to know that you only want half that angle. Because this is for 2 theta times theta, you only want 1 theta. Yes. So I'm going back to those. So I'm going back to here where I have my x is equal to the x prime. So I'm going to say x is equal to x prime times the cosine. Do you care if I do radians? Are you good with radians? So what is the cosine of pi over 4?
Square root of 3 over 2.
It's right up there, people.
Oh no, square root of 2 over 2.
Square root of 2 over 2. And what is the sine of pi over 4? Square root of 2 over 2. My y is going to be times the sine of pi over 4 plus, I'm hoping I'm remembering this right. So this will basically be the square root of 2 over 2x plus the square root of 2 over 2y. New x, new y.
Plus.
Yeah. X is minus, y is plus. Here's my equation. X plus 2 is equal to 0. To make life slightly easier on myself. My equation is x, y plus 2 is equal to 0. I'm going to make this x, y is equal to -2. Everyone good with that?
Why'd you bring that back into play? Like, what did you do this system of equations and then?
Well, before, when we just did the problem, we had a point x, y. We don't have a point x, y this time. Last time we were just transferring a point from the regular x, perpendicular x and y to the rotated x and y. And we're just trying to find the ordered pair for that new axis. This one, we're going to take the equation and we're going to rewrite it so I don't have a term that has x times y. So if I do this right, the xy term should go away. So in place of this x, in place of this x, I'm going to write this because that's what x is equal to.
How did you do this?
I use that formula right there. So I substituted in for theta, I substituted pi over 4.
Yes, but then you went back to the top. Like, I get why you got the x, y plus 2 0.
I subtracted 2 from both sides. So in place of x, I'm going to write the square root of 2 over 2, square root of 2 over 2. That's what x is equal to. In place of y, what am I going to write? The other one. And then this is still equal to -2. Now this may look bad.
What it is.
It is not. I just have to FOIL. I should be excited about foiling this. And I'm going to tell you why I should be excited about it.
Because the square root cancel off.
Yeah. If I'm going through a little thinking man bubble here, if I have A plus B times A minus B, right? These two are the same thing, and these two are the same thing, yes? One has a minus sign, one has a plus sign. So is it not this?
It is.
So when I FOIL that, what do I end up with? So close.
B squared minus B squared.
A squared minus B squared. Yes?
Yes, B.
So if I take this times this, that's going to be A squared. So what is the square root of 2 over 2? What is that?
I'm gonna find out real quick.
Half X.
2 over
Yeah.
4.
So it's 1 of, well, can I write like, well, I have to square this too, right? So can I write like this?
Yeah, I would say so.
And then here's my minus sign, and then I'm going to do the square root of 2 over 2y. And we'll square that.
Where does the square root of 2 go when you do that?
Hold on. If I take the square root of 2 over 2y times the square root of 2 over 2y, that's what I'm doing when I square it, right? Everyone's go with this squared. The square root of 2 times the square root of 2 is 2. And then 2 times 2 is 4. So I simplify these 2 halves to 1 half. So I have that. It kind of looks like a conic, yes? I have something squared and I have something squared. I have a minus sign, which tells me it's what kind of shape. It's a hyperbola. But I should set it equal to what? What? 1. So in order to set it equal to 1, what am I going to divide by? -2. So I have to divide everything by -2. Ooh. I know you're going to ask me this. Oh. So these two are going to switch, right? Because now the y is going to become positive, the x is going to become negative.
Yeah.
So the y is going to become positive, and this is now going to be over what? What's 2 divided by 12 times 1 half?
Nothing. 4, I don't know.
I knew as soon as I wrote that you would not understand what I was doing.
Thank you.
So I cannot erase today. Yeah, I should multiply by 1 half. That would have been better. That would have been a better choice. I'm fixing it. I'm fixing it right now. I'll do that, and then this is still minus, and then this is now x. And this is over 4 is equal to 1. So we said it was a hyperbola, yes? Oh, you know I want to graph it, right?
No, you don't.
If it just says in standard form, yes, that would be done. But since I only have one time, you still don't know. I know. That wasn't what I was trying to do. See how I had this XY term? Okay. The whole point of this was to eliminate that XY term, which I did. I have y squared and I have x squared. I don't have anything that's xy. And then since I have this, I can graph this without a benefit of a calculator because I know how to graph conics. Although no one showed me that on the quiz, but I know how to graph conics. Yes?
So, with the final thing, the graph.
I don't.
Well, if it says this is standard form, we have to write this would end the question, but I want to graph it because I don't have time to get through another one.
Well, if this equation asks you to
I
graph,
just don't get anything.
if you have to graph, is that the final answer, or do you rotate it after you find that?
I'm going to show you how you do it. So I'm going to get out graph paper.
That's where I kind of stop.
When I get out graph paper, you stop.
I don't have that kind of resources.
Come on.
So we're graphing this now?
We're graphing this one.
Oh, I actually dropped that. We gonna get a lot of overcomes.
No.
Let's go. Let's go. Anybody got graph paper?
Welcome back.
Welcome back, Steve. All right, so here I have this axis. My angle of rotation, if I go back up here, was 45 degrees. So 45 degrees basically cuts the first quadrant in half. Yes.
Of course.
So that's my 45-degree axis. I like to remind myself that this is my new x and this is my new y because I'm rotating it counterclockwise. So when I think about this, you guys are drawing those lines on your graph paper, and you're going to pick up your piece of paper and you're going to rotate it so that that new x-axis is horizontal and the new y-axis is vertical. So I'm going to have something that looks like this. You're actually going to physically move your paper.
This is what, is it ever gonna be, like negative 45 degrees?
It could be. No, you know what? No, you guys are going to make it between 0 and 1.
I don't know which one is the X and the Y.
That's why I labeled it, because if I go, this was my original x-axis here, and if I'm going 45 degrees, that would take this and put it here, that would be my new x. That's why I labeled it before I rotated.
But where is it? Like, does it never go the other way?
No, we're going to keep them constant. The angles.
So it's never gonna be negative.
In here, it's never going to be negative.
Well, I'm never gonna do this anywhere else.
You might, you don't know. All right, so do we agree that my center is 0, 0?
Yes.
And then do we agree that my vertices are going to be up and down because the cosines with y? So my vertices are going to be 0, 2, and 0, negative 2, because that's the square root of 4.
Yeah, I would say that.
So then you're going to have to sort of 1, 2, 3, 4, 1, 2, 3, 4, 1.
Wait, but since the y is first, wouldn't it be vertical then? Yeah, it would. So then, yeah, I'm asking that question because, yeah.
So I put my vertice here and I put my vertice here.
How do we know that? Are they the same as the diagram? What is that one?
No, it's smaller than the diagonal.
So how do you?
Just guesstimate.
Square root of 2.
Is one like every corner, like block
No.
every corner?
No, because that would actually be the square root of 2. We had this whole conversation.
So what would one be?
Just guesstimate.
So smaller than
Do you want me to have you start into rollers for this?
No. If you
And you can measure? Then to do the box, I'm gonna go 2 over, and 2 over, and then I'm gonna make my box, because to do
Oh, joy. Making boxes again,
my asymptotes, I'm going to have to do my box. If I notice this, when I look at my box, to go from corner to corner through the center, it's gonna be my old X and my old Y. And that only happens when you're at a 45-degree angle. Oh, that's way too big. Let's go do that. My box is a little bit long.
Yeah, it kind of goes through the corners.
Wait, can you explain that
It's
box
close
again?
The box is to do the asymptote, so I went up and down 2 because that's where my vertices are. I went left, right 2 because that's the square root of X.
Yeah.
I do my box. To do my asymptote, I go from corner of box to corner of the box to the center. Those should be your, for a 45-degree rotation, those should be your old X or Y axes. Then when I graph this, those are my asymptotes. I would graph, go to my asymptotes, and I would do this.
Yeah, that one was. Wait.
I'm going to rotate it back because you guys, of course, would turn in your piece of paper.
Yeah, no, it's so disorienting. Wait, so there's only what?
Wow, look. That's all we had to do for this?
And that would be your graph. If I ask for Coke, I yes, but okay? Good?
This may seem like a really dumb question, but so you only draw, like, obviously hyperbola has only 2 branches, Is it only those two, because those like the where major verses are at?
I think we're calling.
Okay, there's no major minor vertices for hyperbole, and it's only those two because
So that's where the verses are.
those are where the branches are, because that's where the vertices
The
are.
only time you use like the minor verses to draw your box.
Yeah, is for our height, there are no minor vertices,
Well,
but,
that's why I put in air quotes.
but, I can't see air quotes. So the only time you use this for, or the V for hyperbole is to make that box. I wanted to do one more.
We don't have time.
We have like 3 fine, I'm not even on this.
Did you just say?
Just 10 minutes ago? That we're gonna graphic.
We stopped at 21. Any other class? Which means that I think only 2 of those are problems, which means I want your best effort, and I don't want you to go online and just copy what they have, because if you do, I will tell, because they use 1 over the square root of 2 for their pi over
So
4.
just don't do that when you get to it.
Yeah.
Thank you for coming.
Love you as a word.
Bye, Steve.
Adios, Steve.
Yeah, thank you.